All right, so we know the efficiency is 0.347, right? The waste is QC. This is the hardest one, it's 12 joules, right? So we want to find work in QH, right? Okay. Well, so you know what I'm going to do? Well, here I'm going to do it two ways. Okay. The first way I'm going to do it is do this. Okay. Remember that efficiency is work divided by QH, right? We also know QH is the heat that flows into the boiler is either wasted or it becomes work. So therefore, work is QH minus QC, right? So I can rewrite this as QH minus QC. Used to give us this formula, by the way, in the data packet, but they don't anymore. Okay, so now I can set this thing up. 0.347 is equal to QH, which we don't know, right, minus QC, which is 12 over QH, right? Next step is 0.347 QH equals QH minus 12, right? And then a little rearranging, and we've got QH outside of 1 minus 0.347 equals 12, right? And then ultimately QH is 12 divided by 1 minus 0.347. This is a lot of work to do. Okay, but let's just do it. So 12 divided, see if we get the right answer, right? So 1 minus 0.347, and that's 18.4 joules, which is indeed the right answer, right? And then I can just run and get my work from that, right? 18.4, it's 18.38, okay, is equal to 12 plus work, right? So if I subtract 12 from that, I can get my work, which is 6.38. Okay. So this is way number one, and it's good and honest. You have to be able to do this substitution or memorize this, right? Okay. Now let me show you way number two, okay? So here's the heat flowing out of the boiler. Here's the stuff that becomes work. Right. Remember that this is work. It's proportional to the efficiency, right? This is QC. It's proportional to 1 minus the efficiency. And this is QH, and it's proportional to 1, right? So I can actually set up a proportion. Here's my low temperature reservoir, right? Here's our QC. It's at our low temperature. This is our high temperature, right? So I can actually set up this proportion, right? I can say that QH is to 1 as work is to the efficiency, as QC is to 1 minus, right? Because they're efficient to the size of the branches of their Sankey diagram. All right, so this actually is a very simple problem, right? QH over 1 equals work divided by 0.347 equals 12 divided by 1 minus 0.347, right? First thing I do is I go 12 divided by parenthesis 1 minus 0.347. I now have 18.38 or 18.4, which is QH, right? And then I'm going to take that number, just multiply by 0.347 because I'm too lazy to subtract or something like that or think. Okay, and I got, hold on. I did something unclever there. Okay, I'm going to multiply that by 0.347. And I get 6.38, right? So work is, and that's just a fast, simple way to just solve these problems. You can make them harder than that if you want.